In 2013, a survey by the United States Energy Information Administration showed that 2/3 of America's energy came from fossil fuels. 1/5 came from nuclear, 1/10 from geothermal and wind, with less than 1% of America's power needs being met by solar. This is due, in large part, to the relative expense of solar power when compared to conventional power sources. The current levelized cost of electricity for solar power, a cost that factors in the capital investment needed to produce the electricity, is higher by several cents per kilowatt hour than the next most expensive production method. But those costs are decreasing, due mostly to an increase in manufacturing scale. The cost of solar cells has plummeted in recent years, falling below $1 per watt in 2011. While solar cells are less promising in certain regions, when the price per watt falls low enough, they will revolutionize America's aging power infrastructure. Lowering solar panel costs will increase their use and viability across the world. Building up the renewable energy infrastructure would help solve many problems, including global warming and energy dependence. Scientists predict that fossil fuels will run out in the next 100 years. Most everything we own relies on the production of energy by fossil fuels, so a reliable source must be found soon. Currently, the most efficient solar cells we can produce are used in concentrated photovoltaics, or CPV systems. CPV cells can be as much as twice as efficient at collecting solar energy than standard crystalline silicon solar cells. The catch is they are much more expensive. However, we can get around their direct costs by using fewer of them. Mirrors and lenses can bend sunlight and direct it to the CPV cell from a much larger area than normal, drastically increasing efficiency while barely increasing cost. Current CPV technology requires large and expensive tracking systems, along with an expensive pane of Fresnel glass lenses to ensure that the cells receive sunlight at the necessary angle to concentrate it. But if this expensive, maintenance-heavy tracking system could be replaced by a simple, static concentrator, then CPV systems could see a much wider implementation. One possible solution is based on the fisheye lenses used in photography for wide-angle shots. Fisheye lenses use a series of concentric, domed lenses to focus up to 180 degrees of light on the camera shutter. A typical fisheye lens has between 7 and 9 lenses, but the majority of these lenses are only necessary for enhancing the clarity of the picture, not capturing light. If you were to take the two outermost lenses of a fisheye lens and place them over a solar cell, you would have a rudimentary concentrated photovoltaic setup. Further refinement of the lens shape would be necessary to achieve an appropriate amount of concentration, but such a system would drastically decrease costs of manufacture, installation, and maintenance. By extending the domed shape of the fisheye lens out into a cylinder, an entire strip of CPV cells could be placed on roofs with the lenses over them. This static setup would greatly reduce costs of installation compared to a typical CPV tracking system. The only thing standing in the way of implementing this technology is a lack of manufacturing facilities. But if a static concentration system were to go into production, it could greatly reduce the cost per watt of solar energy across the world.